Fiber-reinforced composites is an aggressively growing market. It is expected to touch $388 million by year 2030. Hence, there is enough market space available for new entrepreneur to enter this manufacturing business. Main ingredients include carbon, or Kevlar or glass fibers as reinforcements. Extensively used resins include polyester and epoxy, as epoxy allows production of high-end composites products. Hence, basic properties and characteristics of this material has been described besides the three reinforcements in this lecture for the benefit of students. Strength of any material depends upon tensile strength, density, strength to weight ration and modulus of elasticity that determines its stiffness. Hence, these properties are compared in this lecture for benefit of designers and manufacturers in selecting the most suitable material for any particular application. You can't talk about composite fibers without introducing epoxy. Although reinforcing fibers are used in many applications, if you are a boat builder or aero modeler, epoxy is the substrate you will be dealing with. Although the main purpose of the epoxy matrix is to adhere to and transfer the loads to the fibers, it is a strong material in its own right. Although epoxy bond mechanically if the surfaces are rough, the strongest bond is by far an ionic bond with its reinforcing fibers. That's why not all fibers are suitable as epoxy composite. The epoxy simply does not stick to everything. Due to the presence of volatile organic compounds in epoxy resins, it's always better to protect yourself by working with gloves and at the very least, have a well-ventilated area. Respirators are helpful if you have a tendency to react to chemicals. Epoxy strength is degraded when exposed to higher temperatures than 177 centigrade. Tensile strength is the maximum stress that a material can withstand while being stretched before it fails. Tensile strength is measured in force per unit area, pascals. Ultimate tensile strength, UTS, or ultimate strength terms also used. The next slide shows values of tensile strength. Figures are for comparison purpose. These can vary with the manufacturing process, composition of the epoxy, formulation of the aramid, precursor fiber for the carbon fiber. Units are in megapascals. When making comparisons, it's important to note that there are differences in each of the materials and manufacturing processes, precursor materials, and aftertreatments. These all influence the strength. The figures are given for comparison only. The figures given in this article mostly come from Wikipedia and MetWeb. The denser a material is, the heavier it will feel for an equal-sized chunk. The density is also be influenced by factors such as porosity or the presence of voids within the composite structure. Strength to weight ratio is a measure of a material's strength relative to its density. This property leads to benefits like increased fuel efficiency in vehicles, enhanced performance, and reduced overall weight in structures. Kevlar or Aramid and carbon fibers have a high strength-to-weight ratio when tested unidirectionally in direction of the fibers, while glass has a lower strength-to-weight ratio. Glass is still quite high, just not as good as Kevlar or carbon. The units are kN/meter per kilogram, stands for Newton. When we compare the density of our three materials, we see a significant difference. If you make up three samples exactly the same size and weight, then you quickly see that Kevlar fiber is much lighter. Carbon fiber is next and the glass is the heaviest. So for the same weight of composite we get more strength. Young's modulus is a measure of the stiffness of an elastic material, and is one of the ways used to describe materials. To be more absolutely accurate, elastic modulus is not the same as stiffness. Elastic modulus is a property of the constituent material. Stiffness is a property of a structure containing the various materials. In other words, a material with high modulus of elasticity will make a stiff structure. Again, do not look at the exact figures, they can vary quite a lot. They are useful for comparison though. Stated in gigapascals, the actual figures presented here are for comparison only. The important thing to take away is that carbon fiber is about twice as stiff as Kevlar, and about 5 times stiffer than glass. The downside of the exceptional stiffness of carbon fiber is the fact that it tends to be more brittle. When it fails, it tends to fail without showing much strain or deformation. One speaks of catastrophic failure. The tensile strength of carbon fiber, Kevlar and glass is similar. This comes as quite a surprise to many people. If tensile strength is your only concern, save your money and use glass. The stiffness of carbon fiber, Kevlar and glass are very different. Carbon fiber is by far the stiffer of the composite materials. Choose the most suitable material for your products. Getting guidance from this lecture, and enjoy the benefits of reaping good profits through fiber reinforced composites manufacturing business.